Go. Here we go. Ionic compounds. So we've been learning what ions form from elements. What kind of ions will an element form? The whole reason is so that we can understand what kind of ionic compounds are going to form. So that's our next goal. That's our next success criteria, is that you can name and write formulas for ionic compounds. So I'm going to kind of give you a lot of stuff today to kind of absorb a little bit, and then we're going to start working slowly, practicing doing this, okay? So first of all, yesterday at the end of class, I mentioned the ions that form, we can give them names just based on their charge. We can call them a cation or an anion. We call it a cation if it's positive. We call it an anion if it's negative. Okay, so cation if it's positive, anion if it's negative, if it has a negative charge. Easy way to remember the two is to think of the T in the middle of the word cation as a plus, and that'll help you remember that cations are the ones that are positive. All right? So ionic compounds are just held together by opposite charges. So they're going to have one thing that is a positive charge and one thing that is a negative charge, which means we're going to have a cation and an anion. Those together will make the ionic compound. So really we have these two elements that are close together. One is much stronger than the other. If you remember when we talked about bond types, one is a lot stronger in terms of electronegativity than the other one. And so rather than just share electrons, it's actually so strong that it's going to take the electrons away from the other element, the other atom. When it does that, it's now going to have a negative charge. And since the other one lost electrons, had them taken away, it's going to become positive. So we're going to have a positive and a negative charge. Very important to understand. This is the key right here. Most important thing you're going to learn about ionic compounds is that the total charges have to make 0. Okay? So the total charges for the ionic compound will always be 0. It's kind of like we talked about with the atom in terms of the protons and the electrons. Atoms are always neutral, meaning their overall charge is 0, but it doesn't mean that there's no charged parts of them at all. They do have positive parts and they have negative parts, but those two parts balance out. And that's the whole idea with these ions, is that normally an atom has protons and electrons, the positive and negative charges balancing out. But if electrons are gained or lost, we lose that balance, and therefore the atom becomes an ion. It has a charge. Okay, so on the periodic table, we have these taller A groups. You'll see 2 of them on the left, and you'll see 6 more of them on the right. These are the A groups. We can just look at these to determine how many valence electrons they have, and then be able to use that to determine what kind of charge they'll have. Because they'll either gain enough electrons to get 8, or they'll lose them all. Just like we just did on the pop quiz, right? So the tall A groups, we can find their charges really easy. The lower groups, which they call B groups, not so easy. We can't just do that with. Okay, because the way the electrons are held so weakly, they can just kind of be bouncing around between different atoms. So we can have different charges. So with the lower B groups, we'll actually use Roman numerals, and that will just tell you the charge. Okay? The Roman numeral is always going to be the positive charge. Notice I didn't say charge, I said positive charge. Because these transition metals, being metals, are always going to form a positive charge. You probably have noticed or have a good idea by now that the metals on the left side of the periodic table tend to form positive charges. The reason why is because they have a low electronegativity. They have a low attraction for electrons. Therefore, they tend to get taken away. And if the electrons get taken away, they're going to be positive. All right? So we also have to kind of be able to recognize some names right off the bat. I'm not talking about actual naming yet, but I want you to understand when we see names what it means. So there's a couple different types of ionic compounds that we're going to run into. Okay, so for doing names. The first one, the simplest, is if we have a binary ionic compound. Binary just means two. Okay, so it just has two elements. And those two elements, like I said earlier, are going to be a cation and an anion, which means a metal and a nonmetal. We always list the cation first, the metal. And then we put the anion second, and we change its name so that instead of just naming it like it is on the periodic table, we change the ending to an IDE. So say something like sulfur. Instead of saying sulfur, we call it sulfide. Oxygen, we call it oxide. Nitrogen, we call it nitride. So you use the stem of the word, but then you put an IDE on the end. Fluorine becomes fluoride. Okay? So here's an example. Right down here, I have NaCl. So when we name this, all you do is you just name the first element, the metal, normally. So Na on the periodic table is called sodium. So all we got to do is just name it sodium. First element is always the cation. The second element is going to be an anion, the negative part. So we're going to take the stem of the element's name, which is chlorine, and we're going to put an IDE on the ending. Chlorine becomes chloride. So this compound is actually named sodium chloride. So NaCl, sodium chloride, table salt. All right, another example I wanted you to see, K2O. Now the cool thing about ionic compounds is the subscripts, how many atoms of each thing there are, we don't have to worry about it. Don't even worry that there's two of these Ks. Yeah. All right, so all we do, ignore the two, just look at the K. It's potassium. You just name it potassium. And then the O, which is oxygen, we change that to oxide. So we would name this compound potassium oxide. All right, however, we can also run into polyatomic ions. Okay, polyatomic ions happen when we have more than two elements in the compound. So you'll see this. It's still that we have two ions, but one of the ions is actually going to be a group of atoms together. So we'll see some of this on this next activity we do, which I'm going to go ahead and talk about that now. I'll pause for a second while I pass out this next sheet we're working on. Okay, so the first thing I want you to do, we have this table you see there. They have some ions listed across the top, some ions listed down the side. The first thing I wanted to establish is I want us to write down the charges that these ions will make. Now, zinc is kind of tricky in terms of figuring it out. normally I would just tell you, I will tell you that zinc is going to be a +2 charge. So if you want to write that right above zinc, that would be helpful. The next one is iron, Roman numeral 2. So what kind of charge do you think it has? 2. And it's a +2. Like I said, the Roman numerals are always positive charges. What if it's iron, Roman numeral 3? +3. The polyatomic ions, by the way, I don't know if I noticed this, but if you ever see a name that ends in ATE or ITE, it's telling you it's a polyatomic ion. So to look up the formula for it, you're going to have to look in a special place. They're actually going to have to be found on the back of your periodic table. So when you see ATE endings for ions or ITE for ions, you're going to look on the back of your periodic table. All right, but moving on to this. Gallium, it doesn't tell us a Roman numeral. It is in group 3, however, though. So if we had to guess what kind of ion it makes, okay, a 3+. And silver, I'm just going to tell you what that is. It's a +1. And then what about lead, Roman numeral 4? 4. Okay, what about chloride, Cl? We just saw that in the notes. What group is chlorine in? Okay, nope. Group 7. So it will either gain 1 electron or lose 7 electrons. Gain 1 electron. If it gains 1 electron, what will its charge be? -1. Okay, so you can even write that next to chloride. -1. Okay, so what we're doing in this first table is we're trying to put together the formulas. So this is how we do it. I told you earlier in the notes that the fact that they make an overall charge of 0 is a very important key understanding for you to have. Okay, you've got to have that understanding. In an ionic compound, all the charges within it are always going to add up to 0. Another way of saying that is the number of positive charges are always going to equal the number of negative charges. So they already have one formula written for you. It's zinc chloride, ZnCl2. But why is it ZnCl2? Well, so here it is. Here's how we can picture it. Zinc, we know, has a 2+ charge. So we have this zinc ion here. And then the chloride will make a -1 charge. All right? An ionic compound is always going to form between a cation, the positive ion, in this case zinc, and an anion, the negative ion, in this case chloride. Okay? So this is the positive part of the ionic compound over here, and this is the negative portion over here. So if I look at those charges as they are right now, if I just have one ion of each, do the charges add up to 0? Okay, I have 2 pluses, I have 1 negative. Will those balance out to 0? Okay. They will not. No. Right now I have, if I combine what I have, 2 pluses and 1 minus, they're going to come out to be a +1. So what that means is if we really have this, what we refer to as a formula unit, it's going to attract another nearby chloride ion. It's going to come in here. So if that other chloride ion is involved in this compound, how many chloride ions are there? 2. Now do the overall charges add up to 0? Okay, I have, on the plus side, I have 2 positive ions. Or not 2 positive ions, but 2 positive charges. And on the negative side, I have 1 negative here, 1 negative here, so I have a total of -2 over here. +2, -2, they meet, they cancel each other out to 0. Okay? So that means when I write the formula, I'm going to say there's 1 zinc, so zinc with no subscript, and there are 2 chlorides, which means Cl with a subscript of 2. All right? But that's the key in understanding, trying to figure out their formulas is try to make the overall charge always balance out to 0. So we are going to do just a little bit more in the notes, but before we do that, I want you to try to get into your groups, and I want you to discuss these other boxes in the first row, and I want you guys to try to figure out their formulas. And when you have that first row completed and you think it's right, bring it to me and I will stamp it. And then I just want to tell you one more thing before we leave for the day.